Here we're trying to solve the following problem. We have $280,000 to spend on computers, terminals, and workstations. We have the restriction that we want to have 5 times as many computers as terminals, twice as many computers as workstations, and computers cost $2,000, terminals $500, workstations $5,000. So we have the $280,000 to spend, and these are our restrictions. So what can we do? Well, let's let X1 stand for the number of computers, X2 the number of terminals, and X3 the number of workstations, and see what we can come up with. That's 3 things that we need to know. We need to know the number of computers, the number of terminals, and the number of workstations in order to solve the problem. We don't have any idea what those numbers are, so let's give them symbols and see if we can represent the situation in some meaningful way. Okay, well, let's see. What do we know? We know what the costs are. We know the costs are $2,000 per computer, $500 per terminal, and $5,000 per workstation, so that to buy X1 computers is going to cost us $2,000 X1. To buy X2 terminals is going to cost us $500 X2 terminals, and for X3 workstations, $5,000 X3. Okay? So the total cost is total of these 3 numbers, 2,000 X1 plus 500 X2 plus 5,000 X3. And that's going to equal, of course, our total cost is $280,000. So right there we have an equation for X1, X2, and X3. And that's some comfort, but we've got 3 unknowns. We've got 3 unknowns, and so far we've only got 1 equation. So what are we going to do about that? Well, let's see. We also know that the number of terminals is 5 times the number of computers. That gives us an equation, X2 equals 5X1. And the number of workstations is double the number of computers, X3 equals 2X1. So, now we have 3 equations. We have the first equation that we wrote for the total cost. The second equation we're going to write in this form. X2 equals 5X1. We're going to write that as negative 5X1 plus X2 equals 0. We do this so that we can line up the X1, X2, and X3 with the first equation, because we're going to be adding and subtracting multiples of equations, which is something you've seen before. So you probably understand perfectly well why we're lining these up. In any case, X3 equals 2X2, so we got 2X1, so we have negative 2X1 plus X3 equals 0. And now we have a system of 3 equations in 3 unknowns, and we're going to be able to solve this system to determine the numbers X1, X2, and X3. And we'll deal with actually how we go about solving such a system later. But let's look at another example where we would get a system. Solving the system is pretty straightforward. It's just a method that you use, but the art of putting things into a system is a little more complicated, takes a little more imagination. It's a little more difficult. Now, if we have X1, okay, we're trying to make up a diet. We have gelatin, we have fish, and we have meat. Okay? And we're going to put a certain number of units of gelatin, a certain number of fish, and a certain number of meat into the diet. And we're going to say that we need 600 calories. Actually, I think when I did this in the worksheet, or on the notes, I did it in terms of grams of fat or grams of protein. But we're going to call it calories here. The numbers are the same and the ideas are the same, so it shouldn't make too much difference. So, it's not very realistic in terms of calories. It's more realistic in terms of grams of fat, maybe. We have another condition that's in your notes that I haven't written down here, and I'm not sure why it's not written down. But the condition is that each unit of gelatin contains 10 units of, or 10 calories, let's say. can't figure out why I haven't written this down. But what I'm saying is that, okay, each unit of gelatin has 10 calories, each unit of fish has 50, and each unit of meat has 200. So that the 600 calories that we need will have to be equal to 10 times the number of the units of gelatin plus 50 times the number of fish plus 200 times the number of units of meat. So 10 calories per unit times x1 units of gelatin, 50 calories per unit times x2 units of fish, 200 calories per unit times x3 units of meat. Then I guess we go to protein, and each unit of gelatin has 1 unit of protein, each unit of fish has 3, each unit of this so-called meat has 0.2. Okay, not very, it's probably an imitation meat of some kind. But in any case, then the x1 units of gelatin with 1 unit of protein each will have x1 units of protein. At 3 units apiece, the fish will have 3 x2 units, and at 0.2 units or grams of protein each, the x3 grams of meat, or x3 units of meat will have 0.2 x3 grams. And that's got a total up to 20. Our restrictions are we need 600 calories, 20 grams of protein, and 200 grams of fat. Now, our gelatin, it turns out, has 50 units of fat. So we have 50 x1 units of fat and x1 units of gelatin. Don't know what kind of gelatin this is, because gelatin by itself doesn't have fat, but I guess this is lard-laced gelatin or something like that. At 10 units of fat per unit of fish, we have 10 x2 units of fat, and there's no fat in this meat. It doesn't have much protein, it's got a lot of calories, but it's got no fat. Don't know what it's made of, but that's our restriction here. And that would be the system that we get for this situation.